Hey guys, welcome back to another A Level Maths Made Easy video. This time we're looking at the quotient rule for differentiation. The quotient rule is used when you have a quotient, which is essentially when you have two functions of x dividing each other. Then the quotient rule is very ugly, and it's very particular. So in the product rule, it didn't matter which way round we multiplied the things, right? We could do v times du dx, or we could do u times dv dx, add either way round. But in this case, because we're subtracting, it does actually matter which way round you call u and v. V has to be the function on the denominator. Now, I'm actually going to show you, using the very first question, that you don't actually need to use the quotient rule ever. And in fact, the quotient rule, the way you derive it is you simply use the product rule and the chain rule together in order to get this expression here. So for the first question, I'm actually going to prove it to you. I'm going to use the quotient rule, of course, but I'm also going to just use the product rule, because I think, again, in my opinion, instead of trying to memorize this disgusting formula that's very particular, because it's v minus u, you can't do u minus v, and it's over v squared, not over u squared, that it makes a lot more sense if you use the product rule and the chain rule, because those can be done in any order. So if we use the product rule for something like this, I'm going to change f of x to just y because it's a bit easier. Then I'm going to rewrite this as x times x plus 2 to the minus 1 using those laws of indices. Then if you remember the product rule, we're going to have u is equal to x, v is equal to x plus 2 to the minus 1. We're going to differentiate u. We're going to differentiate v. And remember, this is the chain rule, but remember the shortcut I showed you. What you're going to do is you're going to bring the power forward. So it's negative. You're going to differentiate what's on the inside. So x plus 2 differentiated is just 1. So it's minus 1. So I'm not going to write the 1. Then x plus 2 to the minus 2. Then all you do is you cross multiply. So we have these two times each other. So we have x plus 2 to the minus 1 minus x plus 2 to the minus 2. Now, that would be enough for dy by dx, okay? That would be enough. But as you're probably going to be able to tell, when we use the quotient rule, we're not going to get something that looks like this. We're going to get something that looks like this. So to prove to you that it is indeed the same, what I'm going to do is I'm going to write this in a slightly different way. So we have 1 over x plus 2 minus x over x plus 2 squared. And then you can combine those fractions by timesing the first one by x plus 2 top and bottom. So we get x plus 2 minus x over x plus 2 squared. And then finally, x minus x is just 0, so we get 2 over x plus 2 squared. Now, we can use the top of this. We're going to use the top of this, in fact. So we're going to use this first part, but this time we're going to use the quotient rule. So the quotient rule says v times du dx. So v is this, it's the denominator here, which is just x plus 2. In fact, that's a really good point. Alright, so we're going to have to kind of redefine this slightly. So u is just equal to x, v is just equal to x plus 2. Then we have du dx is 1, dv dx is 1. So now if we do exactly what it says, v times du dx, that's going to be v times du dx just x plus 2. Then it's minus u dv dx, so minus u times this and minus x. So you're probably seeing that it's the same numerator we got here, all over v squared. So that's going to be x plus 2 squared, which again, if you put that all together, we get the exact same answer using the product rule as using the quotient rule. Now, you might say, well, this looks a lot quicker, so why wouldn't I use it? Look, if you want to use it, that's totally fine. But the problem that I see with a lot of students is mixing this up. It is really specific. With the product rule and chain rule, I could have multiplied these in any order. I could have moved them around. And because I'm adding them, it doesn't make a difference. So you have to keep that in mind. Whereas this, you have to do v du dx minus u dv dx. You have to. And you have to divide it by v squared. again, if you think you can remember that, I'm just going to remind you that in an exam, it's very easy to make mistakes with this. So I would recommend just using the product rule, and the students that I've taught, after a while they just say, well, I might as well just remember the product rule and the chain rule. Product rule and chain rule are really easy to remember. Quotient rule isn't. Now, while the quotient rule is quite quick, it is a shortcut, and it is a shortcut. All it is the product rule and chain rule simplified. So I would recommend just using the product rule personally. So I would recommend just doing these as a bit of practice for yourself, but I'm just going to jump straight into them. Again, I'm going to use the product rule and the chain rule. Something that would be quite useful for you if you plan on using the quotient rule is try and use the quotient rule and get the same answer as I do. But again, remember that I'm writing it in a different way than you might expect. Now, if they do say you have to express it as a fraction, you would have to combine the fractions and simplify. But remember, this is the correct answer as well. But if they say express it as a simplified fraction, you have to do the combining. That's only really relevant if you're using the product rule and chain rule. If you're using the quotient rule, it does it for you. So that should hopefully give you enough time to, pause the video and try for yourself. Again, you can use either method that you so well choose. Again, differentiating is a half x to the minus half, and dv dx, remember, you bring the power forward, so that makes it negative. Differentiate what's on the inside, that gives you 3, the number 3, and then you times by the same thing, but you subtract 1 from the power. And then all you're doing is you're cross multiplying. So the first thing we're going to have is, for dy dx, a half x to the minus a half times 3x plus 2 to the power minus 1. And then it's technically going to be a minus because we have a minus here. Timesing those two, we get 3 x to the half 3x plus 2 to the minus 2. And again, that is the correct answer. But if you wanted to simplify it, you would have to times the first one by top and bottom by 3x plus 2 and combine it in that way. Or again, you could just use the quotient rule and get there as well. Doing the same thing over here. Again, we have u is equal to 2x plus 1. We have v is equal to x minus 3 to the power of minus a half. It's minus a half because it's on the bottom of the fraction, so it's negative, and it's a half because it's square root. Differentiating both of those gives you 2. And again, bring the power forward, so it's minus a half. Differentiating that just gives me 1, so it's just minus a half on the outside. X minus 3, the power of minus 3 over 2. And once again, cross multiplying. So yeah, I do personally prefer using the product rule and the chain rule. And if a question does ask me, hey, you need to leave it in terms of a simplified fraction, algebraic fractions is something you need to be good at for A-level maths anyway, so it's good practice for that. Combine them and you do get the exact same answer. I know I'm hammering this home quite a bit, but it is very important that you don't make these kind of simple mistakes, because it can cost you, right? And at the end of the day, every single mark is useful. Most people are within 5 marks of getting the next grade. So if you think about every single mark that you lose to silly mistakes, that could have been what gets you to the next grade up. Unless you get an A star, of course, because there is no higher grade. So the people that get A's are normally within 5 marks of getting an A star. The people that get B's are normally within 5 marks of getting an A, and so on. So you should kind of keep that in mind. So again, while I'm not opposed to using the quotient rule, it's whenever we do tests in school or kind of with my tuition students, sometimes if they use the quotient rule, they make a mistake on it and then they just go back to using the product rule and chain rule because, you get practice with that anyway, right? And it's super, super easy for you. As something to finish off with, because again, there are loads and loads of questions on this, but I don't want you getting too bored. I wanted to show you how you can prove this. So this was actually technically a show that question. And I want you to think about how you can do this, because this, again, is quite useful. Now, you could use the quotient rule, you could use the product rule, you could use whatever you want. But with this, how would you show this? Well, it's actually not too bad. If you think about it, the left-hand side is actually sine x over cos x, which, again, depending on if we want to use the quotient rule or the product rule, in fact, maybe I'll use both just to show you how you can do it. Let's start with the product rule and chain rule, just because, again, that's my personal fave. Cos x to the minus 1. Then all we're going to do is we're going to say that u is equal to sine x, v is equal to cos x to the minus 1. Now, the reason why I'm putting this in brackets is do not confuse this for the inverse cos. It's not the same thing. It's cos x to the minus 1. It's not cos minus 1 x, right? That's why we start using the notation of arc cos and arc sin instead of saying cos to the minus 1. We say arc cos because it is very confusing when you're dealing with reciprocals of cosine functions instead of inverse functions. So, differentiating this, when you differentiate sine, it stays the same sign and it becomes cos x. And when you differentiate this, again, remember you bring the power forward, so that's a minus 1. Then when you differentiate this, you get negative sine, so it swaps sign. So if it's negative cos, it becomes positive sine. If it's cos, it becomes negative sine. So that's negative sine x. So those two are going to cancel out. Then it's cos x to the minus 2. So if I simplify this, we just get sine x cos x to the minus 2. And then again, we're going to multiply and cross multiply and all that stuff. So the first thing, du dx is cos x times that. Well, you can probably see that that's going to cancel out. But, I'm not going to make it too crazy. Then it's going to be add. We get sine x times this. So we get sine squared x times cos x to the minus 2. That looks fine. So that becomes 1 plus, let's call that sine squared x over cos squared x, just to make it a bit easier, which is 1 plus tan squared x. Now, again, that isn't the answer that they've got here, but if you remember, when you have sine squared plus cos squared equals 1, you can divide through by either sine or cos to get certain different values, right? So if since I want tan squared, I'm going to divide through by cos squared. By the way, I should have an x after this. I'm just being completely honest with you. So that makes it tan squared x plus 1 equals 1 over cos squared is sec squared x. So this thing here is equal to sec squared x, which is what we were supposed to show in the first place. Now, when we do it using the quotient rule, you're going to notice something a bit interesting, which is we don't actually need to use this last bit, which is very fun. So if I go back up to the top, just so you guys can follow along, I'm going to copy the quotient rule down. Let's leave it over, let's leave it on top, that makes sense. So in this case, we're still going to write tan as sine over cos. So we get u is equal to sine x, v is equal to cos x. Remember, we don't need the minus 1 because this is defined as v being on the bottom, on the denominator. Because it's defined as that, we don't need to make it cos to the minus 1. Then we get the same type of thing. Du dx is equal to cos x. dv dx is equal to negative sine x. And we're just going to sub it into this formula now. So we have v du dx, so cos x times cos x, that's cos squared x, minus u sine x times, okay, never mind, that's actually plus now. Actually, no, let's leave it as this. Minus sine squared x over v squared, which is cos squared x. So we get, that becomes a giant plus, right? Sine squared plus cos squared is 1 over cos squared x, which is equal to sec squared x. So again, it's just another way to get to the same kind of result, which is interesting, right? Like it's interesting that there's two different ways. We did use the sine squared plus cos squared equals 1, so maybe I should actually write that so people don't get confused. Whereas in the other answer, we used the tan squared x plus 1 equals sec squared, which, again, is different, right? It's nice, it's interesting. Maybe I'm the only one that actually thinks it's interesting, but that's totally fine. But again, we've basically shown the result that the derivative of tan x is equal to sec squared x. And this, just so you're aware, back in the olden days, back when I did the A levels in the 1800s, when we differentiate this, we actually got the result that the differential of tan x is sec squared x. And some students were rightfully complaining about year on year they give fewer and fewer differential results, right? So they give fewer and fewer of these. And the exam board's reasoning is that, technically speaking, you should be able to get from anything you differentiate to the actual answer. This actually includes sin x and cos x. So in year 13, you're expected to be able to differentiate sin x from first principles using the small angle approximation, same with cos x. And then using that, you can differentiate tan using the quotient rule or the product and chain rule. So technically speaking, the reason why they don't give you all of these results is because you can derive them yourself. I don't like that personally, because I don't think, because we're doing maths, we're not doing further maths, we don't need to derive everything. And not just that, the exam is quite short in terms of time. So I don't know if it's particularly fair, because they should give you more time in the exam if they expect you to derive everything yourself. But that's neither here nor there. Here's how you do it. And again, that's basically it for the quotient rule. You don't really need to use it. You can use the product rule and chain rule, as I've said about 30,000 times in this video. But next we're moving on to integration, which is where things get a little bit harder. Integration is coming on a bit later. I think next is actually differential equations, which again is a lot harder. It's a lot more fun. It's also a lot more applicable to real life and to a lot of what your careers are going to be. If you're going to be an engineer, physicist, going into medicine, anything like that, this is going to be your bread and butter. Economics as well.